Hello, receiving students, ATs and receiving teachers. Thank you. Take your seat. As usual, before we go to our main activity for today, let's recap what we have revised in our previous lesson. Now, class, can you tell me what activity did we do in our previous lesson, or what activity did we do in our previous activity? Receiving students, can you tell your teacher what activity you did in your previous lesson? For model class, I'd like to have Michael. Michael, can you tell us what activity we did in our previous lesson?
Median.
Michael says media. Is that media? Michael says media. Did we do that activity? Median? In our previous lesson? Okay, I don't think so. Median was after that. Yes. Katrina. Katrina?
In our previous lesson, we learned about probability.
Probability, good. Probability on activity, what activity? There was an activity that we did. Tossing coin. Okay, the main activity in that lesson, we were tossing coin. And we tossed coin for how many times? 50 times in the main activity. And also we recorded or made tallies of the tosses that we made in 50 times. Tallies of head, head, tail, tail, and head, tail. Those records were also made. Now in this lesson, our main activity will be we will calculate the probabilities of the events that we did in our previous lesson. We will try to calculate the probabilities of head, head, tail, tail, and head, tail. So that is the activity main activity that we will do today. But before we go onto our main activity, I'd like us to look at the board. I would like to explain the theoretical probability of tossing one coin or two coin. This will help us or give us a background information on what lesson that we will do today. So before we go into our activity, let us understand what theoretical probability of one coin and two coins are. Okay, theoretical probability simply means chances of event happening or chances of event that has been agreed upon. So, in this example, what is the theoretical probability of one coin? When a coin is tossed, what is the theoretical probability? For one coin, the theoretical probability for head is half. In percentage, it is expressed as 50%. Tail, it is expressed, theoretical probability is half. In percentage, it is 50%. So, the theoretical probability of one coin of head is half or 50%, and tail is always half or 50%. That's when you are tossing one coin. When you toss two coins, like we did in our previous lesson, we tossed two coins. And the theoretical probability of tossing two coins for head-head, the probability is 1/4 or 25% as percentage. If we express that probability in percentage, it will be 25%. So tossing of two coins, head-head, is always 1/4 or 25%. Tail-tail, it will be always 1/4 or as percentage, it would be 25%. And head-tail, it will be, the theoretical probability will be half or 50% as percentage. So these are the theoretical probability that you expect to get when you toss a coin, one coin or two coin. This is only for one coin and two coin. There is also different theoretical probabilities for tossing of three coin and four coin. I'm giving you an example of only one coin and two coin. But other theoretical probability for tossing one coin, three coin and four coin will not be the same as one coin and two coins, tossing of two coins. Now, our previous activity, in my example, how many times did I toss two coins? How many times did I toss two coins, receiving students? How many times? Okay, if you can recall back to our previous lesson, in my example, I tossed two coins for 20 times. And you did, in your activity, you tossed two coins for 50 times. Now, I have recorded those previous results, tossing of 20 coins. The records are on the board here. So, in the tossing of coins for 20 times, we found out that head-head, the frequency or the tally was 8 and the frequency was 8. We recorded. The result was 8 for head-head, and tail-head was, it's supposed to be tail, not head-head. So, tail, the frequency was 4, and head-tail, the frequency was 8. So these are the results that was collected in previous lesson on tossing of coins for 20 times. Remember in my example. Now, let's find the probabilities. Let's calculate the probabilities of head-head, tail-tail, and head-tail using the results. Experiment probabilities of tossing coins 20 times, two coins 20 times. What is the total number of results that we tossed the coin for? How many times did we toss the coin for? 20. Out of the 20, how many were head? 8. So, the probability is 8 over 20. The probability of tossing coin for 20 times or tossing coin for 20 times and getting head is 8 over 20. Tail. What is the probability? It is 4 over 20. Head-tail. 8. Head-tail, the result was 8 times. So what is the probability? 8 over 20. Now, these are the experiment probabilities of tossing coin for 20 times. Head-head, the probability is 8 over 20. Tail-tail, the probability is 4 over 20. And head-tail, the probability is 8 over 20. Now, let's express these probabilities as percentage. What will be the percentage of head-head? This is the probabilities, probably in fraction. But what will be this in percentage? Receiving students? Who's got the answer? Eddie? Eddie, what is the probability of this expressed as percentage?
40%.
Good. It is 40%. So, the probability of head-head in percentage is 40%. The probability of tail-tail expressed as percentage will be, it would be 20%. And the probability of head-tail expressed as percentage would be 40%. So, this is the result of tossing coin for 20 times. Now, look at the experiment probability and look at the theoretical probability. Can you see some differences there? Is our experiment probability? Compare that experiment probability with the theoretical probability. You will notice that there are some difference. Okay? There are some difference with the results. Now, have that in mind. Why the results are different? Okay? This is the result of tossing coin for 20 times. Now, our activity for today, you are going to calculate the probabilities of the coins, two coins that you have tossed for 50 times. I've just given you an example of how you can calculate the probability. So you calculate the probability of head-head, tail-tail, and head-tail. Receiving teacher, I hope in your previous lesson you have collected the results of your class. I'd like you to give the results back to your students so that they will calculate the probabilities of head-head, tail-tail, and head-tail for 50 times. Now, in that activity, you must be mindful of that, making sure that the results that you get will be closest to the theoretical probability. Our target is the result that we get in tossing of coins for 50%, head-head, tail-tail, and head-tail must be closest to this. That's the thought that you must have. If it is not closest to this, then we have to explain why it is not closest to the theoretical problem. So have that understanding or question in your mind while you are calculating your probabilities of tossing coins for 50 times. Now we will move on to our activity. I'd like runners to come up to the front and collect the results first. Runners from each group. Receiving teacher, you can give the results that you have collected in your previous lesson. Mitchell, give one to each group. Can I have one? Quickly give one. Okay. Activity 1. Receiving teacher, I hope you have given the results. Activity 1 is on the screen. Calculate the probabilities of getting a head-head, tail-tail, head-tail after tossing 2 coins 50 times for your group. So you have the results with you, receiving students, and it is. I would like you to work on your results and calculate the probabilities of head-head, tail-tail, and head-tail. Model class, you have given a worksheet on probability. In that worksheet, you have examples of how you can calculate the probabilities. I've also shown you the example. There's also further explanation on calculating probabilities. So, receiving students and ATs, when you calculate the probabilities, make sure you express your probabilities also in percentage. Express your probabilities in percentage, head-head in percentage, tail-tail in percentage, and head-tail in percentage as well. So everybody should be doing activity 1. Please, group leader, I'd like you to assign people to do different tasks. Group leader, you should assign your group members to do different tasks. Group 2, this is your group's result. You also have it there. Confirm, is it correct? That's your group's result. Seen on your group. Activity 1, you should be using your group's result only. So you find the probabilities of head-head, tail-tail, and head-tail for your groups. Use your result, the results that you have been given. You have your own result there, so you should be using your results. Calculate the probabilities of what you have, the results that you have got in your previous lesson. Okay, I hope you have completed activity 1. Activity 1 shouldn't take you that long because you're going to use your results to calculate the probabilities of getting head-head, tail-tail, and head-tail. Now we will move on to our next activity. Our activity 2, calculate the probabilities of getting a head, tail, head, for all the groups after tossing 2 coins 500 times. Remember, we haven't tossed the coins for 500 times, but we assume that all those tosses that the groups that have made, we combine them together. We have put them together. So the total of toss is 500 times. Now we are going to find the result of getting head, tail, and head, for 500 toss. Receiving teacher, for your class, you might have different results. In the model class, we have 10 groups. So each group made 50 toss, which the total result is 500. In your class, you might have less than that number of group. So 50 times the number of your group will give you the total number of toss. So in this case, we have 10 groups here. So each group made 50 toss times total tossing of coin will be 500. So if you have 6 groups, your total result will be 300. Receiving students, I hope you have understood that explanation. So this is our result here, which is on the board. You might have different results. So you can see group 1, the result of group 1, their head was 17, tail was 14, and the frequency of head-tail was 19. Total of 15. So these are the results. Now you're going to find, I'd like you to make a table like this, and then you have the result and your group numbers on the top, whatever group that you have in your class. If each group, you have 6 groups, so you should have group 1 up to group 6. And the last column that you should have is total experiment result. ER stands for total experiment result. This is the last column that you will have. So you will tell your students to calculate all the results of head, tail, and head-tail. Model class, I hope you are going to do the same activity. So you calculate group members again, assign your group divide your group members, probably this time 2 each, 2% to calculate all the results of head, tail, and head-tail. And don't forget that after you calculate the probabilities, you must also express it as percentage. For the model class, you have been given worksheet there, so you can use that worksheet. An example is also given there. Yes. Activity 2. Okay, this time you did your activity 1, you did only for your group. Huh? Okay, this time you're combining all the results. So you will try to find the probabilities of head, for all this, combining all the 10 groups result. Yes, here. Yep. You have to, you add all this to find the probability. Doing that. Receiving students and ATs, you have a last column there where it says theoretical result. You don't bother calculating that. Okay, you only concentrate on your experiment result. Just a reminder, all your percentage, I'd like you to round it off to whole number, okay? Whole number. If you have decimal numbers, round it off to the nearest whole number. All the percentage, round it off to nearest whole number. Last 1 minute before we go to activity 2. Receiving students, we have last 1 minute before we go to activity 2. Activity 3. Okay, activity 3. Activity 3, compare the probabilities of head-head, tail-tail, tail-head in activity 1 with the probabilities of activity 2. Is there any Is there a difference? If you think that there is a difference, then what is the difference? So that is activity number 3. Receiving students and ATs, I'd like you to make note of that question. Activity 3, write down the question. Last 2 minutes, just sign in one. You say I'm hard correction. So maybe I put in the first 5 minutes. Yes. For the experiment result. Theoretical result. That's theoretical result. What the theory is expected. Theory is required. That's the theoretical. You are calculating the experiment result there. So your experiment result will not be the same as theoretical result. Okay? Yep. Before I wind off the lesson, I'd like us to look at question number 2 or activity 2. Activity 2, remember that on the table that I have given, I have the last column there, which is theoretical result. TR stands for theoretical result. The theoretical result will not be the same as experiment result. So what you are calculating is the experiment result, and this is the theoretical result. So your experiment result will not be the same as theoretical result. Please have that in mind. So this is the experiment result which you are calculating for head-head. Theoretical result, the head-head is 125. What will be your experiment result for head-head? So have that in mind. Receiving students and ATs, unfortunately we cannot correct the activity, but in our next lesson we will, for the first 5 minutes, we will correct the answers to the 3 activities. So each group, you must complete all the answers which have been given in all these 3 activities and get them ready for the next lesson. Next lesson, our first introduction part, we will correct the activity. To sum up the lesson, the formula for finding probability is given on the screen. That is the formula that you can use to find the probabilities. PR stands for probabilities. So if you see that initial, PR, it simply refers to probabilities. Probabilities is calculated as number of successful results over total number of results. So if you can refer back to my example on tossing a coins, the total of tossing a coin was 20 times. And the probabilities, the successful results for head-head was 8. So the probability is 8 over 20. Our keyword for today's lesson is formula. And our next lesson topic will be language of probabilities. And following materials are given on the screen. Receiving teacher, please prepare those materials for the next lesson. Receiving students and ATs, thank you for your participation. This has bring us to the end of the lesson. Thank you.